Let's have a look at the answer to question 3A, part 2. So we've been told, given, that's an important word for us to know because that tells me I'm doing conditional probability, given that the surgery takes less than 140 minutes, calculate an estimate that the surgery, for a probability that the surgery takes more than 130 minutes. Okay, so here we've just got to identify this is talking about a conditional probability. So this is saying what's the probability that the surgery takes more than 130 minutes given that it takes less than 140 minutes. Okay, so there's two parts to this. So I've got the information there about our distribution. It's triangular. There's our ABC values from the up above. And if I go to draw this distribution, 120, 130 and 150. So we've been told given that it takes less than 140, so I'm going to put my 140 on there and I'm just going to shade in everything below 140. So this is what we know. We know it must be in this area here. So given that information, we want to find the probability that it's more than 130. So there's my 130. So we want to find this. So I want to find that area I've shaded in red divided by the area shaded in highlighted blue. So this is what we are doing. We're doing a conditional probability. So this is the same as the probability of being between 130 and 140. And we're dividing by the chance of being less than 140. So this is the probabilities that we need to find in order to get to our answer. So let's do this one step at a time. What we know, as we know from our previous question, we know that the height here, if I was to find that f of x value, we found that already, that was 1 over 115. And that was using our formula 2 over b minus a. Okay, so I know the height at 130. I now need to work out what the height is at 140. Okay, so that's what I need to do first before I can calculate probabilities, is find that height. So I know f of 130 is equal to 1 over 15. And now I need to find f of 140. Okay, so this is where I need to use my formulas. So this is the formulas from the formula sheet. And a reminder, we first have to identify, are we talking about something on the left-hand side of the triangle, or are we talking about something on the right-hand side? So do I want the value between A and C, or between C and B? And if we look at our value of 140, our 140 is on the right-hand side of the triangle. So it's between C and B. So that means, in terms of the formula, I want to use the formula that's between C and B. So this is the formula I'm going to use to work out the height. Okay, so finding the height at 140 using that formula we've highlighted. So our value of B, so remember we've got that here, A is 120, B is 150, C is 130. So I can say 2 times B, my maximum, 150, minus X. Now what is our X value? Well, our X value is the 140, because that's what we're trying to find. So that's my A, my B, my C, and my X. So X is 140. And I'm going to divide that by B minus A. So B is 150 minus my minimum, 120, times B, which is my maximum, minus C, my most common, 130. Okay. So simplifying that, 150 minus 140 is 10. 10 times 2 is 20. And then on the bottom, simplifying the first bracket, 150 minus 120 is 30. And 150 minus 130 is 20. So these will simplify, those will cancel down to leave me with 1 over 30 is my height at 140. And I'm going to leave this as a fraction, not a decimal, because I don't want any rounding errors coming in. Okay, so that's what we've just found. We've found the height at 140. So there we go, our height at 140 is 1 over 30. So those are, just make a little note there, those are our heights. Okay, so now that I know the two heights of my triangular distribution, now I can try and work out some areas. So one thing that I notice when I look at this is that area that I've shaded in red between 130 and 140, that whole area there is actually a trapezium shape. So as much as I love working out trapeziums, I'd rather work out triangular shapes. Okay, so in what I can do in this case is I notice that this little piece here is a triangle. So I could work out the height of that little piece. And if I know the piece on the between 120 and 130, then I can reason and work out what the whole probability will be. So that's what I want to do. Okay, so I want to start by finding the area. I'm just going to draw that little bit there. So I want to find from 140 to 150 with a height here of 1 over 30. I just want to find that tail area. So our probability, which is our area, is half the base times the height. And in this case, our base from 140 to 150, that's a base of 10, and our height is 1 over 30. So let's go 1 over 2 times 10 times 1 over 30. And I'm just going to leave that as a fraction, 1 over 6. So that is 1/6. So that's what I found, is that the area of that piece there, so this yellow piece that I've got there, the area of that is 1 over 6. Okay, now we did find, remember, from the previous question, the chance of being below 130. And we found that that chance of being below 130 was 1/3. So this piece here is 1/3. The yellow piece there is 1/6. And we know that the whole probability has to add up to 100% or 1. So I can use that reasoning now to work out the area between 130 and 140. So let me just jump down and find some space here. So what I want to do now is I want to find the area between 130 and 140. Now I know that this piece over here is a third. I know this piece over here is a sixth. And so I can say the probability of being between 130 and 140 is 1 minus a third minus a sixth. And if I go 1 minus a third minus a sixth, that gives me a half. So that tells me this area there is 0.5 or is a fraction of half. So that's how big the area between 130 and 140 is. Okay, so let's jump back up to here. So I know that this area there is 0.5. Okay, I now have all the probabilities I need. Now what I need to do is actually work out my answer. So now I actually need to calculate this. All right, so I'm going to get some space down here. And so we want the probability of and it was the probability of being between 130 and 140 divided by the probability of being below 140. So the chance of being between 130 and 140, we found that. That's this value of 0.5. And now I've got to work out the chance of being below 140. So I'm going back to my diagram. The chance of being below 140. So that is this whole area here. That's my chance of being below 140 that I've just been re-highlighting it there. So we know that one part of it is a third, the other part of it is a half. So the total area together, I'm going to add those together. So it's a third plus a half. And when I put this into my calculator, I'm going to just make sure I put brackets around that so that when I do the division, it actually does it correctly. So I'm going to do 0.5 divided by 1/3 plus a half, which I could have done as fractions, which is 0.6. Or we could write that as 3/5. Okay, so either of those. So there is our answer to this conditional probability for a triangular distribution.